All right, IBAASL2. Today we're going to talk about measures of dispersion, which is like how spread out the data is. The first word that we're going to use is called range. You guys have probably heard this one before. The range is just the biggest value minus the smallest, so the max minus the min. So it's a number of, the distance from the top to the bottom of the data. The next words we're going to start using are the quartiles. Now notice how quartiles has that word quarter in it, or part of quarter. That's because quartiles split the data up into quarters. So if you split the data up into quarters, you're splitting it up into 25% chunks. So the first quartile, which is called Q1, or it's called the lower quartile as well, has 25% of the data below it. Second quartile, which is also more commonly called the median, has 50%. So remember, I'm going to highlight 25 for Q1, 50% for the second quartile. And then the third quartile, which we will call Q3 from now on, has 75% of the data below it. Now, the way you find these quartiles is sort of the same way you find medians, except for you split the data in half, into a lower half and an upper half, and then Q1 is the median of the lower half. Q3 is the median of the upper half. The last vocab word we're going to use today is the interquartile range, which is called the IQR from here on out, and that's just Q3 minus Q1. So it's the distance between the first and upper quartile, or lower and upper quartiles. First example, we're going to take this data set and find the median, Q1, Q3, and the IQR. So the median, you could use the cross-off method, but I recommend using kind of the formula that I gave you guys. First, we need to know how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if there's 12 pieces of data, that means the median is going to be the 12 plus, that's for the odd. For even, it's the average of the 12 over tooth and the 12 over 2 plus 1th. So that means that this is the average of the 6th and the 7th piece of data. So 1, 2, 3, 4, 5, 6, 7. So this means that the median is right here. It's the average of 36 and 49. Did I do that right? Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, there's 6 in the lower and 6 in the upper. So 36 plus 49 divided by 2 is 42.5. So that means that the median is 42.5. 36 plus 49 over 2 is equal to 42.5. Now, you guys, if there's 6, so if I just look at the lower half of the data, there's 6 pieces of data. 1, 2, 3, 4, 5, 6. So I need to find the median of those first 6. Using the formulas again, that means that the median is going to be between the 3rd and the 4th. So if here's the first 3, and then here's the next 3, that means that the Q1 is the average of 9 and 16 together. Now, we're just averaging because it's an even set of numbers. If it had been an odd set of numbers, it would just be the number that's in the middle using the n plus 1 over 2 formula. But 9 plus 16 divided by 2 is 12.5, I think. So there's our Q1. Q1 is 12.5. If I do the same thing for the upper set of data, so there's 6 pieces of data in the upper, and then I go 1, 2, 3, 4, 5, 6, Q3 is going to be the average of these two. So it's going to be 81 plus 100 divided by 2, which is 90.5. Then the inner quartile range is just 90.5 minus 12.5. So it's Q3 minus Q1, which is 78. The range is the biggest value, the max, which is 144. So this guy's the max, and then 1 is the min. So 144 minus 1 is 143. So there's the quartiles, the inner quartile range, and the range. Now you can take those numbers and translate them into what's called a box plot, or sometimes this is also called a box and whisker. The way this works is that this number here on the end is going to be your minimum. This is going to be your maximum up here top. This bar right in the middle is going to be your median. And then this ends of the box are going to be their quartiles. So this is your lower quartile, and this is your upper quartile. Please remember that all of this splits the data into 25% chunks. So also they wanted me to say that the range is from here all the way over here. So range is from the bottom to the top. The quartiles means that this is 25% of the data, and then this box is 25% as well. This is 25%, and then this upper whisker, oh yeah, those are called the whiskers, is 25% as well. This is a whisker. The box is in the middle. This is a whisker as well. I think that's it for a box and whisker plot, or a box plot as they're called. Now, we need to have a discussion about outliers. So I always start with an example like this. 1, 1, 2, 2, 3, 4, 17. I always throw this up and ask students, like, hey, is there an outlier in this data? And kids usually go, yeah, the 17 is an outlier. And then I go, well, how do you know? And they say, well, because it's far away from the data. Like the data is all 1, 2, 3, 4, and then 17 is very far away. So then I say, okay, well, what if I change that to like 10? Is it still an outlier? And kids go, yeah. And then I go, well, what if I change it to 7? Is it still an outlier? And they go, maybe. And I go, well, what if it's 6? And they're like, no, I don't think 6 is an outlier. So I'm like, so there is some cutoff of how close it is to the data that makes it an outlier or not. That's absolutely true, and here's the formal way to do it. Outliers are above the upper boundary or below the lower. So above the upper boundary or below the lower boundary. The way you find the upper and lower boundaries is with the quartiles, Q3 and Q1. So the upper boundary is Q3 plus 1.5 times the IQR, and the lower boundary is Q1 minus 1.5 times the IQR. When you go to make your box plot, you need to check for outliers. So this right here is just an example of a box plot. Oh yeah, I forgot to mention on my box plot up here that you need to put the number line underneath it that contains the data. So this is just a specific example for this box plot, but those numbers can change based off what the actual data in your problem is. So if you check your boundaries, and let's say that all of it was within the upper and lower boundary except for one number which was past the upper boundary, then what you do is scoot a whisker over to the next data piece. So this is like next biggest data piece. And this is your outlier. This would be the same as if you had an outlier on the lower end as well, that you would scoot this whisker over to the next highest data piece and then put a star over there. Or it's possible you could have multiple stars past a whisker, but your outliers do need to be labeled as stars on a box plot. Now, we're going to embrace the calculator for this unit, and I'm going to teach you guys how to find the quartiles using your GDC. On a TI 83/84-ish model, you're going to hit Stat. Here, I'll do this too. And then Edit. In fact, let's do it with this problem set we're going to do right now. We're going to find the quartiles of this data set, which we could do with our kind of counting off or find, the formulas for finding the medians and stuff. But it's really quick on a calculator. So hit Stat, hit Edit. Now, if you already have data in your L1, you might need to clear L1. And the way you do that is you highlight L1 and hit the clear button and then hit down, and it should just clear the entire list. Now we're going to push all this data right here into L1. So 37, enter, 43, enter, 43, 44, 44, 46, 47, 47, 47, 47. How many 47s? There's 4 of them. 1, 2, 3, 4. 1, 2, 3, 4. Oh, wait, is there 5? Hold on, I'm miscounting. 1, 2, 3, 4, 5. Yeah, there's 5. Then a 48, then a 51, then a 52, 53, 54. Once you have those all pushed in, then you're going to hit Stat again. But instead of hitting Edit, you're going to arrow to the right and do Calc. This is a whole Calculate menu. And the very top one is 1var stats. Hit Enter on 1var stats. And then depending on what model you're using, you'll see it'll throw it on your home screen, or you'll see this little menu. On my 84 plus silver edition, it says like list, frequency list, calculate. Just make sure L1 is in the list spot and arrow down to calculate. Now, when you hit enter on 1var stats, you're going to see a whole bunch of stuff, but really the first menu you're not concerned with. So scroll down and you will see the min, the max, the Q1, the Q3, and the median. So the median in this case is 47. Q1 is 44. And Q3 is 49.5. So we're going to put this on a box plot. The smallest piece of data is 37 and the biggest is a 54. So 37, 54. Then Q1 is 44. So I'll put a bar on Q1. Then the median is 47. So that's in between my tick marks. And then the top is 49.5. So we'll just have to do our best to estimate that one. It's right here. Then you connect these to make your box, and then you put your whiskers. There's the box plot. Also, sometimes instead of bars on the ends, you can put a dot. They seem to switch back and forth between this, so I'm fine with dots as well. Now, technically, I really should have checked for outliers before I built the box and whisker plot. It's because if you build the box and whisker plot first and then you find an outlier later, you have to erase part of your box and whisker plot and put a star there for the outlier. The last part of this says determine whether 37 is an outlier. Well, 37 is the lowest piece of data, so we really need to check the lower boundary. The lower boundary is Q1 minus 1.5 times the IQR. So in this case, that's 44 minus 1.5 times the IQR, which is 49.5 minus 44. So 44 minus 1.5 times 49.5 minus 44. 35.75. No, something's wrong there. I think I hit something wrong. Oh, 44 is not the... No, it is. Maybe they did something wrong. Hold on. Oh, my upper quartile seems wrong. Maybe I missed a number in the original, like translating from the book. But if this is the upper quartile, then this means that the lower bound is 35.75, which is below 37, which means 37 is not an outlier. Which is good, because then I'd have, like, if it had been an outlier, I'd have to redraw my box plot and put a star on 37 and then make the left whisker whatever is the next biggest number, which would be 43. All right, you guys. Good luck with your homework. Come ask me questions in class.